Hello! Yes, and welcome to our Objective 2.8 notes. Objective 2.8 says I can solve right triangles, and that's what we're going to do today. But first, I just want to review a couple things, make sure we're all set to go. First thing I want to review is our trig ratios. So I just want to remember the sides that we look at when we're dealing with these different trig ratios. So remember that the sine of theta is the opposite over the hypotenuse. Cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. Cosecant of theta, the hypotenuse over the opposite. Secant, the hypotenuse over the adjacent. And cotangent, the adjacent over the opposite. Now, today we're going to be really focusing on these three here, sine, cosine, tangent. And those are the ones that we're going to use most when we are solving right triangles. So, what does it mean by solving a right triangle? So to solve a right triangle, you need to find the measurement of all three sides and angles. Alright, so with these examples here, solve the following right triangle. Be sure to label your sides and angles appropriately. Here's what we're going to do. So we have three angles, angle A, which would be this angle here, angle B, which is they're given to us, it's 74 degrees, and angle C, which is 90 degrees. Fantastic. Now, we also have side A, which is the side opposite of angle A. So this would be side A, and to notate our sides, we use lowercase. So side A, side B, and then side C is given to us. Side C is 10. So, what this means now is that we can use just this information, the 90 degree angle, 74 degree angle, and a hypotenuse of 10 to find angle A, and side B. So let's start with angle A. That'll probably be the first one. Well, we know that the interior angles of a triangle add up to 180 degrees. So all I need to do is subtract 90 and 74 from 180. So angle A will be 180 minus 90 plus 74. So let's go ahead and put that in our calculator. 180 minus 90 plus 74. And when I do that, I get 16. So angle A, we can say confidently now, is 16 degrees. So now I have two sides. To find our sides, we're going to use trig ratios. So what I would suggest is let's start with side B. Okay, so this side here. And the reason I chose that is because side B, to figure that out, we can use, notice we have this angle of 74. This is our opposite side, and this is our hypotenuse. So we can use trig, specifically sine, to figure out our side length for B. So I'm going to say the sine of 74 equals opposite B over hypotenuse 10. Multiply both sides by 10. Now I would say that B equals 10 times the sine of 74. So let's go ahead and put that in our calculator. 10 sine 74, and we get 9.61. Let's round to the nearest hundredth, so B equals 9.61. If you got a different answer than that, something you might check is make sure that we are in degree mode. So if you hit mode, degree, make sure it says degree, not radian. Okay? So we now know side B. For side A, we can use that same angle 74. This time it will be cosine because it will be our adjacent in our hypotenuse. So to figure out A, we can say the cosine of 74 equals A over 10, our adjacent over our hypotenuse, which means that A will equal 10 times the cosine of 74. So I will say 10 cosine 74 and 2.76. And there we go. There's one way to solve a right triangle. Let's try again. Let's do another. So notice here, This time we have, again, triangle ABC. We know that angle A is unknown for us right now. Angle B is 21 degrees. Angle C is 90 degrees. Side A we don't know. Side B we do know, right? B would be 12. And side C, we don't know yet, our hypotenuse. So with that being said, let's figure out here. Let's start with angle A. So angle A will be 180 minus 21 plus 90. So in my calculator, I'll do 180 minus parentheses 21 plus 90. And when I do that, I get 69 degrees. Nice. Okay. So now that I have my angle A, let's go ahead and work on side A. So side A would be this side here. So think about what I can use here. I have this 21 degree angle. I have an opposite side and an adjacent side. So opposite and adjacent, this would be tangent. So to figure out side A, I would say the tangent of 21 degrees equals my opposite, 12, over my adjacent, A. Okay, so I need to multiply both sides by A, so I have A times the tangent of 21 equals 12. And then to get A all by itself, I'd divide by the tangent of 21. Of course, I'd divide both sides by that tangent. So I would have A equals 12 divided by the tangent of 21. And that's what I'm going to put in my calculator. 12 divided by the tangent of 21, close parentheses, 31.26. And now for side C. Some people think, hey, Mr. Carter, if we have the two sides, can't I use Pythagorean's theorem? You can, however, we rounded side A, so we want to avoid using any rounded figures in additional calculations, as that would just make those additional calculations even more inaccurate. So let's avoid using any rounded figures. Let's go ahead, figure out what side C would be, or what side C would be using trig. So this time we will use the sine function, because it'll be our opposite and our hypotenuse from angle B. So it'll be the sine of 21 equals 12 over C. And from the same process that we did up here, we know that C is going to be 12 divided by the sine of 21. So 12 divided by the sine of 21. Now think, this is our hypotenuse, so it should be our biggest side yet. Let's see if that's true. 33.49. Yes, indeed. Awesome. And that's how you can solve a right triangle with trig. Now, for both of these right triangles, they gave us an angle. What happens if they don't give us an angle? Well, if they don't give an inverse angle, we can use some inverse trig. Okay? And that's used to find the measurement of an angle in a triangle where you know the sides. So what we're going to do here is use our calculator. We can use the second sine or second cosine or second tan. And those create sine inverse, cosine inverse, and tangent inverse. Now notice, let's look at letter A here. We want to find this angle. So this would be my opposite side, this would be my adjacent side, this would be my hypotenuse, of course, across from the 90-degree angle. Alright, so if I say I want the sine inverse of my opposite is 56, my hypotenuse is 65. Well, let's figure out what we get here. Sine inverse, so second sine inverse of 56 divided by 65. 59.49. Now what's cool is look at what happens when I do maybe cosine inverse. So cosine inverse would be my adjacent 33 divided by my hypotenuse 65. So cosine inverse of 33 divided by 65, and I get, what do you know, the exact same thing. And look at tangent inverse. Tangent inverse would be, let's see, my opposite, 56, divided by my adjacent, 33. And when I close, oh, that says 3. Divided by 33, there we go. What do you know? The exact same thing. So all of the different inverse trig ratios will give you the same measurement for the angle because this angle obviously is that one measurement, 59.49 degrees. All right, let's try letter B here. Instead of doing sine inverse first for this one, let's do cosine inverse. Why not? So we would have our opposite side here, our adjacent, and our hypotenuse. So our adjacent would be 39, my hypotenuse 89. So let's see if this checks out here. So second, cosine inverse of 39 divided by 89 equals 64.01 degrees. Let's see if that's the same for our sine inverse maybe. So sine inverse of 80 over 89 will equal sine inverse of 80 divided by 89. And if we did this right, what do you know? It's the same. And I bet tangent inverse would probably be the same too. Let's find out. My opposite, 80 over my adjacent, 39. Second, tan inverse 80 divided by 39. Hey, what do you know? All the same. How cool is that? Okay, so that's how you can find the angles if you only know the sides. So with that being said, let's solve some more right triangles here. Let's look at letter A. Notice they gave us two sides. Crazy. So we have angle A that we don't know. We have angle B that we don't know. We do know that angle C is 90 degrees. We have side A is 3, side B is 8, but we don't know our hypotenuse, side C. So if I wanted to find angle A, this would be my opposite, this would be my adjacent, right? So I can say tangent inverse of 3 over 8 equals, let's put that in our calculator, 3 divided by 8, 20.56 degrees for angle A. Now, what does that mean angle B has to be? Well, it should be right around, what, 70 degrees, 69 point something here. Let's see if we get that, because angle B would be tangent inverse of 8 would be my opposite side, right? This would be my opposite, and this would be my adjacent for angle B. So let's do tangent inverse of 8 over 3 and see if we get that around 69 point something here. 69.44. Wow. How did I know it was going to be that? Because I knew that these two angles had to add up to 90 degrees, right? In order to give me that 180. Perfect. So now all we need to do is find side C. And side C we can do quite simply using Pythagorean's theorem. We could use trig, but again, since these are rounded values, we don't want to use them because they will cause our calculations to be even more inaccurate. So let's just use Pythagorean's theorem. So a squared is 3 plus b squared, 8 squared, equals c squared. So that's 9 plus 64 is c squared. So that would be what? 73 equals c squared. So c is the square root of 73, which I can put into my calculator, and I'll say second square root of 73 equals 8.54. Well done. All right. Now let's do one where they do give us an angle. So let's write out what we know. We know that angle A is 32 degrees. We don't know angle B. We know angle C is 90 degrees. Side A, it says, is 8.5. We don't know side B, and we don't know side C. All right, this would be side B, this would be side C. We don't know those. So let's start by figuring out angle B. So to figure out angle B, I can do 180 minus 90 plus 32. In my calculator, 180 minus parentheses 90 plus 32. And that will give me 58 degrees. So we know B is 58 degrees. Now let's do some fun math. So let's do some trig. To figure out sine B, given our 32 degree angle, this would be our opposite. B would be our adjacent. So opposite, adjacent, we're talking about tangent here, aren't we? So we'd say the tangent of 32, there we go, 32 equals our opposite, 8.5, over our adjacent, which is side B. So multiply both sides by B, divide by tangent of 32, we would get B equals 8.5 divided by the tangent of 32. In my calculator, 8.5 divided by the tangent of 32, close parentheses, enter, 13.60. Very good. Okay, now to figure out C, think about what we have here. Let's see, C is our hypotenuse. So we have our opposite and our hypotenuse. Opposite and hypotenuse is sine. So I'd say the sine of 32 equals 8.5 over C, which means that C will equal 8.5 divided by the sine of 32. 8.5 divided by the sine of 32, close parentheses, and when I do that, 16.04. Well done. All right, so there's some ways to solve right triangles. Now, the last thing I want to show you in these notes is what if they just tell you about the triangle? They don't actually tell you, you don't actually get an image. Well, we can use this information just fine. So the first thing we need to do is draw a triangle. I think it's so helpful to draw the triangle. Okay, so let's just create a right triangle, something like this. Let's see. We know that angle F is 90 degrees. We know that side D is 5. That means this must be E. And we know that F is 14, side F. Okay? So let's write out now what we know and what we don't know. We do not know angle D. We do not know angle E. We do know angle F is 90 degrees. We know side D is 5. We do not know side E. We know side F is 14. Okay, so notice they didn't give me any angles other than the 90 degrees, so I'm going to have to use inverse trig here. So let's start by figuring out angle D. All right, to figure out angle D with some inverse trig, remember angle D would be this angle here. So I have my opposite and my hypotenuse. So I do the sine inverse of my opposite, 5 over hypotenuse, 14. So second, sine inverse, 5 divided by 14, close parentheses, enter, 20.92 degrees. And then to do angle E, that would be this angle here, I would say, okay, I need my cosine inverse of 5 over 14. Because now it's my adjacent over my hypotenuse. Cosine inverse, 5 divided by 14, close parentheses, 69.08. Now notice I did this right because those two angles add up to 90 degrees, so I'm feeling good. And then for side E, I can use Pythagorean's theorem. So I'd say 5 squared plus E squared equals 14 squared. So 25 plus E squared equals 14 squared. It's helpful to put in our calculator, but it's 196. So I'd say E squared equals 196 minus 25. What is 196 minus 25? It is 171, which means that E is the square root of 171. So in my calculator, second square root 171, it'll be just over 13, 13.08. And there we go. That's how we can solve a triangle. Notice now we have all the angles and all the sides for this triangle. Let's do one more together and then we'll call it a day. So triangle HJK, and again, I'm just making up a triangle. I don't care if it's accurate, remember? Remember that what we can pull away from images, we can't pull away side lengths or angles or anything like that. So it doesn't matter if it's accurate. We're just adding a picture here. So I have J, H, and K. K is 90 degrees. J, it says it's 63 degrees. That's good to know. And then side H would be this side here. It is 8. So let's write what we know. So we know angle, or we don't know angle H. We know angle J is 63. We know angle K is 90 degrees. And then we know side H is 8, but we don't know side J and we don't know side K. This would be our side J, this would be our side K. Okay, but we do know an angle, so we can use some trig here. So let's start by finding angle H. So for angle H, I would say it's 180 minus 90 plus 63. And that's going to give me 17. All right, here's it 27. Let's do it in our calculator just to be sure. It's totally 27. 180 minus 90 plus 63 equals 27 degrees. So now we know that angle H is 27 degrees. Let's use the angle they gave us, though, J, to figure out everything we need to. So let's start by finding side J. Side J would be the opposite of the 63 degree angle. So I would use my opposite and adjacent, that's tangent. So J would be the tangent of 63 equal to my opposite J over my adjacent 8. So that means that J will equal 8 times the tangent of 63. Let's put that in our calculator. 8 tangent 63, close parentheses, 15.70. And now for side K, that would be our hypotenuse. 8 is still our adjacent. Adjacent hypotenuse would be cosine. All right, so K would be the cosine of 63 equals my adjacent 8 over my hypotenuse K. So that tells me that K is going to equal 8 divided by the cosine of 63. 8 divided by the cosine of 63. And if we did this right, it should be our largest value yet. Yes, 17.62. All right. And that was a lot, but think of all the different ways we just learned how to solve right triangles. We learned how to solve them if no triangle was given. We learned how to use inverse trig to solve them. And we learned how to solve them if we had an angle measurement just using trig. All right, I hope you all are feeling good. If you want some more practice and more examples, go ahead and look at those sample problems. Otherwise, feel free to get started on your practice problems. This is Mr. Carter signing off. I'll see you next time.